Hey there. What's up?
Hello,
Hi, how are you?
I'm doing good. How are you?
I'm good. I like your Mario and Metroid or maybe Metroid posters.
Yes,
And
huge Mario Nintendo fan.
very nice, very nice. Yeah, awesome. Nice meeting you. So why don't you tell
Nice meeting you as well.
Thank you. When are you taking your test?
So I plan on taking the MCAT in September,
Got it.
probably around like the last date that you're able to take it in September.
Yep. Third.
Um,
Have you
yeah.
the MCAT before?
Yes, I've taken the MCAT before. I've taken it twice before,
Okay.
but the difference in my score was very minimal. I think I only went up like 4 points.
Do you remember what your breakdown was? If not, that's okay.
I would say my breakdown is my best section is biology, biochemistry.
Mm-hmm.
Um, Biology, biochemistry was around like a 34, 35%,
Mm-hmm.
which is like around a 124. And
Okay.
then my other sections are not good. Like my other sections are just straight 120s.
Got it. Got it. Okay. And when did you take these tests before?
So my first MCAT exam I took back in 2022. And then my second MCAT exam, I took that last year in July of, yeah, 2024.
Got it. All right. And have you done the AAMC full lengths?
Yes, I have. I have done the AAMC full lengths. That's the only full lengths I do take. Um, I know with the AAMC, they're the most representative, so I try to stick to those.
So you did all of them?
No, I have not taken all of them.
Oh, which ones have you taken?
I've taken the unscored AAMC full length, but that was last year. And then I've taken AAMC number two, and then recently last week, the one that I'm going over right now, I took AAMC full length number three. I heard four and five are you're supposed to wait for those until you're about to take the exam. So
Uh,
I'm just gonna.
yeah. So okay, let's see. So you took the sample unscored last year. You took when did you take AMC 2?
AAMC two I took in February or January of this year.
Okay. And did you take full length 1?
Yes, I did take full length one, but I don't remember when I took that.
Okay. Have you take All right, so you haven't taken any of the third party exams. Okay. So I am going to make a let's see. So for the sample and for the full length one, you either well, the sample you took last year and full length one you don't remember when you took it. So I would say those we could probably do like a retake at
Hmm.
some point. Um, and I would also say, so let's see, one, two, three, four. Okay, so let's do this. Let's have you start with I guess we can go over questions from your most recent full length, but here, let me share. screen. Let me know when you can see my screen.
I can't see anything. It's just okay. I see it now.
Okay, cool. So this is going to be like a calendar spreadsheet that we're going to use to keep track of everything. So in this full lengths tab, I put in your scores and for let's say, yeah, so you're probably going to take it September 13th. So going backwards from that, like let's say that you take a test a week, this will be your full length four. So wait, let's see. So full length four, two, one, and scored. Okay. Full length, that was four, one, two. And I actually, so I'll tell you, like, I guess after you take this test, but people, I know people say to take, I know people call the scored exam full length five,
Hmm.
but it isn't full length five. It's the scored full length. That's free. And that's going to mean something. If I tell you beforehand, it'll alter your score. Um, so I'll tell you afterwards. But yeah, we will have that be the first AMC full length that you take after like we, like do some other stuff, which I'll talk about. So let's say that August 16th, likely you'll take it. And now if we can fit in a full length for one, two, three, four, maybe five of them. I would recommend Altius. Have you ever taken them or, well, I know you haven't taken them, but
Mm-mm.
heard of them or anything like that? Okay, so like, uh, yeah, so they're really, really good tests. They're on the hard side, so it's going to put you like in the position of taking like harder practice tests, like not just harder in terms of like difficulty, in terms of like the questions and passages, but the passages are going to be a lot longer, a lot more dense. It's going to be like a nightmare, but that's good practice. And what I usually have my students do is I separate the entire study, like I guess like regimen into three phases. So the first phase is just the Jack doing the Jack Weston content diagnostic, and this is a good like active way to be able to identify content gaps, and then we can review those content gaps. So how to access that is you go to the Jack Weston website, which looks like this, scroll down to the Jack Weston MCAT QBank, hit Study QBank now. And then over here, it says MCAT Content Diagnostic. Select that.
Mm-hmm.
Then there's three. There's BB, there's CP, there's Psych and these
Right.
are just discrete questions. They're not like passage based or anything, so shouldn't take you too long to do them. But basically, this is a way for you to be exposed to every like high yield topic that the MCAT can ask you. And when you review it, when you review it, you can consult these last tabs here, the content tab. So I basically took the AMC content outline and I put it into spreadsheet form. This is for CP, this is for BB, this is for Psych Soc.
Mm-hmm.
And so like when you do the content diagnostic, like let's say you're getting questions wrong in, I don't know, like let's say um buoyancy. you could just do like a control F and you can search for it, and then you can see, okay, so like this is what's fair game on the MCAT, like what the AMC expects us to know. We need to know buoyancy, Archimedes principle, we need to know hydrostatic pressure, Pascal's law.
Okay.
Yeah, hold on, I think this is wrong. I have to check that. But um yeah, and then you can use this drop-down menu to indicate your level of understanding. So like if you get it wrong on the Jack Weston content diagnostic, I would put your level of understanding as weak. And then you can review that topic. Do you have UWorld?
Yes, I do.
Okay, okay. So um yeah, so you could like yeah, so like from the content diagnostic, you'll review it after you do it and you'll see like okay like this is something I got wrong and maybe you'll read the solution, maybe it'll make sense. You'll then do some UWorld practice on it, like practice passages, practice questions on that topic, and if you start to get them right in UWorld you can raise your level of understanding from weak to okay.
Hmm.
And we're going to leave it at that until we get to the full lengths. And if you're getting these topics wrong on the full lengths, we leave it at okay. But if you're getting them right in the full lengths, we can raise your level of understanding to strong. And so this is just a good way to make sure that we have like, because there's a lot of different like approaches to content review and stuff like that. And most of it's passive and most of it if it's passive it's like you don't really know if you know it to the like as well as you need to in order to like answer the questions and stuff like that. So this way we get to pinpoint exactly which content areas you may have some weakness in and exactly like from the AMC like exactly what they expect us to know. So
Right.
that's for the first phase. Are you using Anki?
Yes, I am. So what I currently do, like my uh full length three that I'm doing right now, whatever I get wrong,
Mhm.
I take a screenshot of it and I put the passage. If it has a figure, I put that, and then I have the question,
Hmm.
and I just basically re-ask myself, why is this question correct? And then I have to recall,
Hmm.
like, okay, it's correct because of A, B, C, D,
Hmm.
and why the other ones are not correct.
Got it. Are you using any like pre-made? It's cool that you're making your own decks, by the way. Like, are you using any pre-made decks?
So I am using the miles down for
Yep.
physics, and then also I have not really looked at the biology, biochemistry yet because that's like my strongest section right now. So I'm just putting that off to the side. And it's organized by section. So if I need to look at fluids, which I'm not good at, I just go to that specific section and it has the equations and everything in it, so I can just recall that.
Got it. Yeah. So I would say that for the mile, yeah, so the Miles Down is a great deck, and yes, within it there's decks, um, and particularly the essential equations deck, right? There's that in Miles Down.
Yes.
So I think that that's a good deck to like start there to start with just so you get all of the equations down just because you don't want to like lose points from not knowing an equation. And I would focus on that for like this week. And oh, and then yeah, and then after that we can think about which other I guess like content areas to focus on. And I would also recommend like the Mr. Pankow deck, which is have you heard of that one? It's a
Yes, I have.
yeah, it's a pretty good Psych Soch deck. And so yeah, we can have you focus on that and the Jack Weston content diagnostic. Now for cars, what have you been doing for that?
Oh, so for cars, I have been trying to do a cars passage, at least one every day. However, so I've been using the UWorld cars mostly, but for like my UWorld cars is not representative of the Jack Weston or the AMC cars. So
Yeah.
like the UWorld cars, I'll get like say there's 6 questions, I'll get 5 out of the 6 correct. But
Mhm.
then when I go on Jack Weston, I'll get 20%. So it or when I go on the AMC, I will miss a whole entire passage.
Yeah.
So I'm just not sure if the UWorld cars is being as helpful. I know any practice is good practice. However, the scores are not matching. So,
Yeah. So I would say for UWorld, don't bother with the cars that they have. For cars, let's only focus on Jack Weston and AMC. So for the AMC cars, you have the like Cars QPAC Volume 1, Volume 2 diagnostic tool, right? You did?
mhm.
Okay, and like have you like tried them? Have you yeah.
I am currently using um, the volume one. I have volume one right now.
Yep.
The only one that I did so far is the one about Shakespeare.
Okay.
But then I have not completed the whole thing yet.
Yep, yep.
So should
Yep.
I do all of that in one sitting?
Oh no no no. No, that'll be
Okay.
just like yeah. So we sh like I would say the next time we meet, we will have like a dedicated cars session because I want to show you the strategy that I use with my students and we're going to use and you're going to use that strategy like as you move forward. So for each day here, like basically like you'll be doing like so with Anki like you don't have to spend too much time on it. Like I don't really measure it in terms of like how many cards you get done. I measure it in just how much time it takes. Oh yeah. Oh, so you mentioned I think that like this is your main focus for the summer? Like you're not doing other stuff,
Oh,
right?
so my yes. So I work part-time. It's not even a lot of hours per week. And I also volunteer in the anatomy lab with some students. So I just do other things on the side, but this is my main focus right
Got
now.
it. Okay. Yeah. So for each day, yeah, I would say to do 45 minutes to an hour of Anki. And for this week, the Jack like your main focus is going to be the Jack Weston content diagnostic.
Mhm.
And then for cars, you'll be doing like yes, either from the AMC QPAC that you're working on now, or from Jack Weston. They're both equally pretty good. Um, and yeah, just for this week, I guess, focus on the Jack Weston content diagnostic until we meet next. And the next time we meet, we'll go over the car strategy. Now, we might be able, if you get the Altius tests, we might be able to fit a test in on Saturday, but if not, we could just fit it for the Saturday after. But basically, for these full lengths, what you'll be doing is you'll be like so like let's say this is the Altius full length one that you take. So I also wrote here, so for the Altius full lengths, don't use their cars section, use Jack Weston cars practice exams instead. So that means for Altius, like you'll take, you'll start the test, you'll take the CP section, timed like everything. And when you get to the car section, just open up another tab with for Jack Weston. And then
Mhm.
just on the left sidebar, go to practice exams. And there's these cars practice exams. There's Los Angeles, there's Chicago. Don't worry about these ones like history, economics, philosophy, because those are specifically those categories, and that's not how, it'll appear on the test. So, for instance, for the first Altius test, like, yes, you'll take the CP section, and then when cars starts, open up another tab, go to the, Jack Weston practice exams, do this Los Angeles cars exam. It's like a self-contained cars exam. You just hit go to the exam. And you do that, timed and everything, like it's a real test, get your score, whatever. And then when you're done, you go back to the Altius, skip the cars, do the BB and Psych Soc. And
Okay.
yes, and now so that'll be for let's say, for let's just say like if this is on the Saturday over here.
Mm-hmm.
So once you take that test and you get your score, like you're done for the day, nothing else, don't do anything else that day. And then the next day, you'll do something called a blind review. And what that is you basically, from your exam, you write down which questions um you got wrong. The Yeah, you write down which questions you got wrong, trying not to look at the answers, and then you do a redo of that test, untimed, like no time constraint, and you only do the ones that you got wrong the first time. So this way we get to separate the questions you got wrong because you really didn't understand them from the questions that you got wrong because you're really running out of time. So this way we can, so like for instance, if let's say for CP you get 15 wrong, you just write down what those 15 questions are. You do
Mm-hmm.
your new attempt untimed, just doing the 15 that you got wrong. Also like if you got a question right by guessing, that counts. So do that as well. And you'll probably get some of these 15 questions right. Let's say you get seven of them, or let's say you get eight of them right, and seven of them are still wrong. Then you can do your regular review where you read the solution. And if it makes sense, um, you're good. If it doesn't, if it doesn't make sense, let's say three of them still don't make sense. When we meet, we can focus on those three rather than, the 15 here. So this way you basically get to like, before we meet, you like exhaust all your other resources. So when we meet, we go over like the really, really nitty-gritty kind of like hard stuff. So that'll be like what you do on Sundays. And then depending on, so like let's say from this full length that you got, and it's going to be similar workflow to like the content stuff. Like let's say you got some questions wrong on like acid-base titration. You can go to the CP content tab, Control F, titration, and you need to know this. You need to know, let's see what else pops up. Here, titration. So everything in this indicators, neutralization, interpretation of the titration curves, redox titration, all of that. And yes, that way you identify areas that you could still use some work in. And then during the week, you'll do UWorld, I call it like a targeted content review, where you do UWorld questions and passages on like titration. So like basically when you take your full length, you're gonna be like reacquainted with some content areas that you might need some more work in, and then you can do that and practice that with UWorld, do the week.
Mm-hmm.
Like that'll be the main focus for the week. And I would say like, we should meet sometime like in the beginning of the week to go over your previous full length. And then during the week, you'll be doing a lot of UWorld. And then sometime towards the end of the week, we should meet to go over um, UWorld, questions from UWorld. And then you'll take your next practice test, same thing. Um, blind review, regular review, and then we'll meet to go over questions from that. And then you'll be doing UWorld, and then like towards the end of the week, we'll meet to go over UWorld questions, and then same pattern. So this, yeah, so this way, let's see, I can fit in five or like four of the UWorld tests. Sorry, the Altius tests. And once we finish that, we'll start the AMC ones again, and that's going to be the phase three. And at some point, you'll be like towards like the end, you'll be so like like as you start, you can use like both Jack Weston and AMC for cars, but
Mhm.
by like the last 2, 3 weeks, we'll be focusing specifically on AMC material. So that's when, so like we'll aim to like finish UWorld, not their cars, but everything else, like let's say by like August 22nd or something like that. And then the last week of August, we'll be doing the AMC section banks. And then, the week before, you'll take your test. I mean, your last practice test. And yeah, that's pretty much the schedule. Yeah, and we'll input your scores here. And yeah, what do you think? The
I think this plan is very good and it's structured.
Mhm.
Um, my only concern is I know how I am when it comes to questions that I get wrong. I go down a rabbit hole. Like I'll open up all these tabs and I'll have YouTube videos open and Khan Academy open, and then I'll just watch video after video after video, and I'll be one, stuck reviewing one uh content section for an hour.
Mhm.
So how do I avoid doing that? So I'm not sitting here at
Yeah.
my desk for 4+ hours going over, say, aldol condensation for organic chemistry. So,
So first question is like, sure, let's say it takes an hour, but at the end, do you like feel like you understand it well?
um, after that hour is kind of like, okay, I get it, but if I see this question again, am I going to get it right?
Okay.
Probably not.
Got it, got it. Okay, so I think that um for let's say the rest of the time, let's go over like the AMC full length 3 that you just took. Why don't we go over some questions or passages that you might have from that? We can kind of see, it'll give me a better idea of exactly.
Okay, let
Mhm.
me um, let me go ahead and reload this. I'm gonna log back in.
Mhm.
Okay, um, I have it up here. Let me go ahead and
Mhm.
share my screen. Can you see my screen?
Yep.
Okay. So, like for this question, because I feel like the reason why I got this right is only because I kind of did like a organic chemistry review before going into this full length. So I feel like that's why I kind of got some of these organic chemistry questions correct.
Mhm.
But you see, like this one, I got correct. I didn't find this question very hard. I just kind of counted the carbons away from this CH3 here, and then that's how I got the answer.
Mhm.
Um, and then this question I got correct as well. What can we infer? Thermodynamic stability. I saw the percentages. The one that's more thermodynamically stable is going to be the one that's made most, so 60% of this. That's how I got answer C.
Mhm.
But then once I started getting into aldol condensation, which one is not followed by a dehydration reaction, I wrote down, I tried to go from back from the beginning, like how did they get that answer? And
Okay.
I was like just kind of going over it and writing it down, but I was not able to figure it out how they did it. No way.
Okay. Let's see. Let me see the passage. All right. So like how do you approach the passages?
So when I look at these passages, I read the passages before I look at the
Good, good,
questions.
because most people don't do that, and they have all sorts of crazy things. Like they read the questions first, and then they go back, and it's ridiculous. So good job, good job. That's like the first right. Like that's most people. A lot of people don't do that, but good, very good, good, good.
So I look at the passage and then I say, okay, synthetic pathway compound is this, it's referring here. There's two steps to get to scheme A. So
Mhm.
then I look at the reaction right here. So I say it's a alcohol is going on right here. And
Wait.
then
Oh, tell me a little bit about what you said right there.
oh, I said this is a like an alcohol is
So,
happening in this step between compound
so
2 and 3.
sorry. So this, what happens when this goes into water?
When it goes into water, it's going to make it more basic, correct?
So tell me like how? Like what happens exactly?
So this C double bonded to
Oh,
this
sorry,
O is going to
this. Just this over here? What I circled?
oh I'm not sure.
Okay, okay. So um what happens when this goes into water?
Oh, when it goes into water, this is going to separate into sodium and chloride, correct?
All right, and tell me about what those like look like if I drew them. Would it just be this and this?
No,
Okay.
but I'm not exactly sure.
So just try it out. So like for instance, right, when Na and Cl are together, it's a neutral compound, right?
Hmm.
And then when it goes into and they're connected by like an ionic bond, right? And this is just like table salt, right? So
Hmm.
basically, when you put it in water, it dissociates into sodium plus and chloride ion, right?
Yes.
So a lot of times, whenever you see and so in the same period, like the same column rather, um, potassium is there too, right? And so they
Hmm.
all behave the same way. Like if you had KCl, this will also dissociate into K plus and Cl minus, right? So whenever you see potassium or sodium or anything else from that first group, and like same thing for usually like the second group, like they will dissociate.
Hmm.
So now let's say we have KOH. Now, since we know so and also that first group, the first column, uh turns into a plus one ion, right? Um,
Yes.
and then the second group will turn into a plus two. So, and those will always be like true, like their oxidation states don't change. So, whenever you have so something like KOH, what do you think this would break up into?
So that potassium is just going to dissociate into just K plus.
Hmm.
And then the OH is going to dissociate on its own into minus.
Perfect. Good. So now OH minus, super strong base, right?
Mm-hmm.
Good. So them saying the zero point 0.1 equivalent of KOH. So it's like you did identify like there like in an alcohol there is an OH group, but also in an alcohol it's an organic molecule, right? So it's a hydrocarbon, like you'll need to have a carbon involved. Like if you had CH3OH, like
Mm-hmm.
methanol, like that would be an alcohol, right? And that wouldn't dissociate or anything like that, right? Um,
Right.
Okay, so now that we know that the KOH really is this basic, sorry, one second, I have someone at the door. All right, sorry about that. So so the KOH is the hydroxide base, and it's going to, well, okay, so like two things. So like one, even if we didn't even look at any of this stuff, like we don't even look at that, um, you can just see that compound one looks like this, compound two looks like this, compound three looks like a combination of the two, right?
Mm-hmm.
And where do you think, so it seems like they make them connect. Where do you think they connect?
So they're connecting at this this carbon right here.
All right, and show me where that is on, you know, the ones on the left.
That would be right here.
Hmm. So that's where it'll attach to compound one, and where on compound two would it attach to?
That would be right here.
Very good. Okay. So that's most of it right there. Like they might talk about, things that sound scary, like Aldol, whatever. Um, but at the very like, basic level, you can just see that, okay, we have this compound, it looks like that, this compound looks like that. Compound three connects them and it connects them here to here. And that's pretty much how you get this. And then what happens? Like from compound three to like these guys.
So from compound 3 to the two different types of compound 4s,
Hmm.
it looks like you have a six-membered ring being formed,
Hmm.
and along with the five-member ring on the right-hand side.
Got it.
So, and then you also have, let me see, this double bond of O and C that is, um, I'm not really sure what's going on there. I know it collapses and then it reforms with the aldol condensation.
Yeah.
So I'm just a little bit confused on back here. You
Mm.
have this double bond and then it turns into one, two, three. And then how does it, my main concern is how is it turning into a six membered ring? I think that's what's getting me caught up on these questions because I'm constantly staring at it. I'm like, oh my gosh, how did they do that?
Got it. Okay. So we can see that. So we have one carbon, two carbon, three carbon, four carbons. And if we make, let's see, so here we have one, two, three, four. So we must be making a bond between, I'll kind of label this. Let's say carbon one, two, three, and four.
Hmm.
One, two, three, and four. So we must be making a bond between carbon four and this guy over here, right?
Correct.
So, okay. So that's how that ring is going to form. Um, and does that make sense how like you go from that in the ring? Okay.
Yes. Mhm.
So, all right. So basically, we looked at we didn't even look at any reagents or anything like that yet. We just see that okay, compound one and compound two turned into compound three, so they must connect at here to here, and
Mhm.
then this ring closure happens. So this fourth carbon here must connect to this carbon here. And okay, that's what we're looking at. So now we can look more into the specifics. So they say here that okay, so in this over here, so they say step one. So yeah, I would when you're reading this, I would like yeah, look at it and try to and just be like okay, like this connects here, this connects there, etc. See how you can go from the reactants to the products. And then you can read the part of the passage. So it tells you, and this can just help you make sure. So for instance, if you were thinking this was like an alcohol, it says here step one involves the base promoted nucleophilic addition of
Mhm.
compound one to compound two. So so we know that like something here. Oh, so this guy is actually your alcohol, ethanol, right? It's just that.
Mhm.
And but this one is the base, right?
Correct.
So okay, what do you think that base is going to do if you add it, you know, to either compound one or compound two?
That base, um, isn't it going to because it's negative,
Hmm.
it's going to attack that carbonyl carbon or the C double bonded to the O because it's partially positively charged.
Okay, so very good. That is what will like typically happen like 99% of the time. Usually though, if you have because if you think about it, right? Um, for instance, if I had this and I want to use if I want to add so okay, in like a synthesis, you want to add other organic molecules, other hydrocarbons.
Hmm.
And you can do that with nucleophilic addition, and that's like 99% of what it'll be about, exactly what you just said, so that you just got a very, very good fundamental like concept down, which is like that. And I always say that like your um, hydroxyl group is going to be the most common nucleophile on this test, and your carbonyl group, because of that partial positive, is going to be the most common electrophile on this test. And it's for the purpose of So like if I was using this ethanol as the nucleophile, the purpose would be to add like the oxygen in addition to these carbons, right?
Okay.
Now, in the case of KOH, where we just have OH minus, it doesn't have any carbons or anything like that attached to it, right?
Mm-hmm.
This is actually not going to act as a nucleophile, but it'll act as a base. And they're very, very similar. Um, but in general, if they say the word base or if they say the word acid, the default definition is going to be the Bronsted-Lowry definition, which means, an acid donates a proton and a base accepts a proton.
Mm-hmm.
When they talk about nucleophiles, though, that's when your nucleophile, it's going to be the Lewis definition. The nucleophile is your Lewis base, which is a electron pair donor, and your electrophile is a Lewis acid, which is an electron pair acceptor. So they're telling us that a base is involved and bases do what bases do, which is they accept protons, which could mean that they can deprotonate something.
Mm-hmm.
And it will also involve a nucleophile, I guess, for of compound one to compound two. So, so let's first think about the base removing a proton. And we know that something must happen either here or here, right? So which do you think is more likely to lose a proton?
So most likely to lose a proton would be compound two, right here,
All right.
in my opinion.
Mm-hmm. So let's see. So compound two, this is like if I zoomed in on that, this would be like a CH2, like double bond here.
Mm-hmm.
And if it lost a proton, this will be a CH minus, like this. And you have a double bond there. Now, for compound one, where you have this ring and this carbon or methyl attached to the ring is a tertiary one. And um, so like it's going to make a carb anion. And whenever you have either a carb anion or a carbocation, which is the like the positive version of that, um, would it be more stable if it was like let's say tertiary or like secondary or primary or something like that?
Oh. Um, if it was a primary, I believe it would be more stable only because it's directly bonded. So there's I'm not really sure, but
Uh-huh.
I would say primary is more stable.
Okay. So here, like I just kind of drew, it looks like a line, but it's really like just like if this OH group over here got removed or something like that. Like, so this is a primary carbocation here, and then this is a tertiary carbocation here. And in anything, if you can spread a charge, so the entire
Um,
reason why something like this is reactive is because there's a separation of charge, right? There's a partial negative here, a partial positive there, right?
mhm.
Okay. Now, if this didn't have a separation of charge, like, let's just say, or let's say that we had like an ether like this, since it's symmetric, um, it's not going to be, though you don't have a separation of charge, and it's not going to be like polar, right?
Correct.
So now, so that's just to think about it, things as separation of charge. Because, like, for instance, the dipole goes here because the oxygen is very electronegative and it pulls electron density from the carbonyl carbon. Whereas for this one, the dipole goes here from these carbons and the dipole goes here from those carbons and they cancel out.
Mm-hmm.
So basically, if you could spread a charge across a larger area, it's going to be less um, polar and more stable because it
Okay.
can spread across a larger area. So a primary carbocation like this, or like I'll just draw like a secondary one like that. So this is a secondary one, and this is a tertiary one. The tertiary one can spread that charge across the three um, carbons, or I guess four
Mm-hmm.
carbons, compared to the secondary one, which can uh, spread it out across two. So for these two, like if this one, if yeah, this double bond on the compound two got deprotonated, it would just be like a CH minus with that double bond, which will kind of behave like a primary almost carb anion. But
Okay.
this one can spread, it's like it's going to be a tertiary carb anion, and it can spread that charge across the three, or I guess four carbons here, right? And so
Yes.
that's why, there's that like methyl group there. So, okay,
Mm-hmm.
so that's going to be the one that gets deprotonated. And also, it says the nucleophilic addition of compound one to compound two. And so that means that compound one is going to behave as the nucleophile.
Mm-hmm.
And compound two is going to behave as the electrophile,
Okay.
right? So we're going to get, so this is going to be negative because of the KOH, and then this turns into this tertiary carbanion, which is very, very, stable here. And it's going to nucleophilically attack this
Okay.
carbon and form a bond with it. And it's kind of just like when something, let's just say whatever, something like this attacks this carbon, right?
Mm-hmm.
Because, well, granted, this over here doesn't have the partial positive and partial negative, which is why here you could use like an alcohol as like a nucleophile and stuff, which is just gonna be um, you know, partially negative instead of full-fledged negative. Um,
Mm-hmm.
but this one here, like, yeah, it's not gonna have it's this double bond here in compound two isn't polar, so that's why you need a full-fledged negative charge to nucleophilically attack that. So now if in this case, like if I added the ROH to this and it forms a bond with it, it would look like it forms a bond here, and since the carbon can only make four bonds, it pushes this bond up here, right?
Right.
To look like, let's say this,
Okay.
right? And typically it reforms that bond and it kicks something off, like a leaving group. So here, um, I guess it doesn't really need to kick anything off because it can just move this double bond over to give you the essentially a single bond. Um,
Hmm.
and then you can get this molecule on the right.
Right.
Does that kind of make sense?
Yes.
Tact.
Yeah, that makes sense. I understand why uh
Hmm.
you made a really good point here with the tertiary versus the secondary versus primary.
Hmm.
I completely understand that now.
Hmm. Got it. Yep. And then we have, yeah, so then we have this compound three here, and we seem to add essentially the same thing, right? And
Hmm.
uh aka, the base. So it's gonna do what a base does, and which is deprotonate. What do you think, which carbon do you think it'll deprotonate on compound three?
It's gonna deprotonate this carbon right here because of the same thing with the partially positive.
Does that carbon have any hydrogens?
Oh no, no, it doesn't.
Hmm. And we
Okay.
already know from what we talked about before, right? That like one, two, three, four, right?
Hmm.
That carbon four is gonna attack this, right?
Right. So it would it it would deprotonate carbon four then
Yep.
in that case.
Yeah.
Okay.
So now you might be thinking like, okay, wait, that is like seems like it's like a primary carbon. Like, why does that get deprotonated now? If we just said prior, it had to be tertiary. So now the alpha carbon, aka the carbon that is adjacent to the carbonyl carbon,
Hmm.
it's going since it's pulling that electron density, it doesn't just pull it from the carbonyl carbon like through the inductive effect, it can pull it from the alpha carbons as well, making an alpha carbon more acidic than normal.
Right.
So this, yeah, so this carbon here is going to be more acidic by nature, and
Hmm.
like that is going to help. I mean, we're still adding really, really strong base. Um, I guess technically they might be using less or something like that, uh, but 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 yeah. So we're gonna have so basically like three ways of looking at this. Like one, the most basic way is like, okay, these two compounds turn into this. So, there must be an attachment of this to this. And then this compound turns into these. So there must be attachment of this to that. That's the most basic way of looking at it. And that's going to help you out, a lot. And then after that, you can kind of look at it in terms of like how they're describing it. Uh, because like just from them, like, right, like they're not gonna just give you this scheme A and just, expect you to know everything about it. Um, so thankfully, they'll tell us a bit about it. Um, but let's just say they don't. If we think about what an aldol condensation is, just think of it as you are going to make, um, let's see. Well, I'll say that. So typically you're going to use, it's like, okay, so usually organic chem reactions will be what we talked about like earlier, like this kind of thing. nucleophile attacking, some hydroxyl group that's typically a nucleophile with an
Mm-hmm.
R group attached, attacking like a carbonyl carbon. That's 99% of what you'll see. Um, but if you have a strong base being added to deprotonate something and then cause some type of like synthesis, that's going to be your aldol. And it's an aldol like condensation, and then condensation part means that water is leaving, like
Correct. Yeah.
dehydration step. So you're gonna typically have that happen. So okay, so now same kind of thing. We're gonna have a net. This is gonna get deprotonated. It'll be a negative charge, and it's going to attack this carbonyl carbon here to turn into this ring. And
Mm-hmm.
that's pretty much what we have here. So now they're telling us that, okay, the resulting product compound 3 cyclizes via an intramolecular means within the molecule, aldol condensation reaction. All right, cool. The cyclized product, which is not shown, so that's basically like, this thing here that they didn't really draw. So like let's
Right.
whatever, it's over here and it'll look like, you know, basically it'll basically look like that, except without this double bond here. And I'll actually just draw it. So it'll
Are
look,
they referring to an intermediate product
yep,
that they didn't show?
yeah.
Okay.
Hmm. So this would look like, so this is going to be, so let's see, this is still going to be here, or rather here. And since it's attacking this oxygen, I'll label it orange, is still attached here, and it's negative, like that. And
Mm-hmm.
so what happens is, so this is the cyclized product that's not shown. Should look somewhat like this, with this orange oxygen still there. And so this is going to take, there's also a hydrogen here that this is going to get pulled off, and like essentially the electrons from this will go here to create the double bond here, and you're going to get water come out as a product.
Mm-hmm.
That's the condensation step. And so like condensation, like, it's just another word for like dehydration. So they refer to it as a dehydration step here. But yeah, that's what they mean by the dehydration reaction. Um, so that's what happens. That leaves, and then we get our double bond there. Um, and it makes a thermodynamic mixture of the isomeric products, compounds 4A and 4B. So when they say a thermodynamic mixture, they essentially mean that one is more stable than the other, as
Mm-hmm.
opposed to like if they did like a kinetic control or something like that, that's going to be regarding speed. So like, if they'd said that it was like a kinetic control or a kinetic mixture with the same values, like 60%, this is going to be the one that's produced fastest.
Mm-hmm.
But since you're saying thermodynamic, it's going to be based on stability. So compound 4A at 60% is more stable than compound 4B. Um, and the only real difference between them is that the, I guess, 4A has this like isopropyl group um, with a black wedge and this black wedge for the methyl group over here. And then over here, the like isopropyl group or whatever is like the dashed wedge.
Hmm.
Okay. And then they say compounds 4A and 4B are carefully separated, and compound 4A is eventually converted to alpha catenol back to this up here through further reactions. Let me take another look at alpha catenol. All right. Okay. So they do some other stuff with 2 compound 4A to give you the alpha catenol. Okay. So yeah, that's pretty much what we what we want to like obtain from a passage like this. So yeah, so like first, like don't worry about the details as much. Just look at, okay, this and this combine here. So there must be a connection between here and here. And then from here to here, there must be a connection between here and here. And that's like, the most like fundamental way of looking at it where you don't even need to worry about aldol condensations or worry about like the reagents being used or any of that stuff. You could just see like the bare bones, like what's actually happening. Like if this turns into this, it turns into that, and like everything else has to follow that. Um, and then I would say um, that the passage helps by telling us, for instance, here, like it's a base promoted, so this is acting as a base, nucleophilic addition of compound 1 to compound 2. So if you didn't remember that like KOH is just a base, and if you didn't uh remember or think about like the how like a tertiary like carbocation or carbanion in this case is more stable. The passage tells us, and yeah, that's pretty much it. Yeah,
I get caught up on the details.
yep, 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 yep. So, um, yeah, so that kind of stuff, and like that's because like so pre-meds are very, very thorough people, and it's like, how do you create a test for a pre-med? Like, how do you make a test hard for a pre-med? You make a lot of like this over here, like zero point 0.1 equivalent KOH, ethanol, and then at 2O, like, oh, that's actually this. Like, I didn't even realize that. But which is an ether. But yeah, that and then the 0 Celsius and 4 hours, like there's so much stuff going on there, but that's not going to be important. And then here, 10% KOH over ethanol, reflux, 2 hours, like that, those types of details are not going to be important. So you want to just have like be able to zoom out and have a really like big picture kind of understanding of it.
Okay.
Yep.
Yeah.
So,
When I get caught up on the details, I try and nitpick and
mhm.
see, okay, is this gonna help me in any way? Or maybe this is important.
Yep.
I don't look at the big picture.
Yeah.
So,
So like
uh,
I would say being able to draw like the mechanisms of this stuff can really, really help. And I think that's something that a lot of like orgo classes like may not focus on as much. Like a lot of orgo classes, like they just have like some molecule and then like some reagent and then some other molecule.
mm,
And it's like they try to make you just remember the reagents and remember what they do. But if you can understand like the mechanism, like the exact atom that gets deprotonated and then connects to this other thing. Like all this stuff with the arrows, like that's gonna be like the most important thing, I would say.
Mhm.
So, okay, let's take a look at this question. And good. All right. So now also the way that we went over that passage, like that's also like kind of ties in with like the philosophy of like really understanding the passage because the ideal is that you understand the passage so well that you can anticipate questions.
Right.
So this is one that we uh probably already here, let me erase some stuff. Already like drew. I think it might be like the thing that I drew over here. Yeah. So, okay, which of the following compounds is most likely to be a major product in step two if the aldol condensation was not or is not followed by a dehydration reaction? Okay, so now the MCAT is also something that makes it tough is that they're rarely just going to ask you like a very straightforward question. Like the question's going to
Mhm.
be something, it's rarely going to be straightforward. So making sure you understand the question is key. And a lot of people like really overlook that because they're
Mhm.
just kind of like trying to go as fast as possible. But what is this question essentially asking us?
Okay, so what it's saying is um, major product in step two if it was not followed by the dehydration reaction. So,
Yep.
what would be the product if we don't involve water leaving? So,
Yep.
like, if water doesn't leave, what is the product? Because we know that if water leaves, we're gonna get this.
Yep.
This is the final. These two are the final products.
Exactly.
So, What will it look like if we don't have that? That's what I got from that question.
Good.
Um, and so if water is not going to leave,
Hmm.
we still need to have, I know this now, we still need to have that OH, uh, that alcohol group there
Hmm.
because it's going to come in from here. So it would,
So
yeah.
let's go back up there. All right. So this so remember, okay, so this orange oxygen, and then this becomes CH2 minus. This
Hmm.
attacks that, right? And just like here, when you have something nucleophilic, so this is like when you have this attack this, right?
Hmm.
And it forms a bond, and it pushes this double bond from the carbonyl up to the oxygen to make it O minus.
Hmm.
So now this attacking the carbonyl would do the same thing, right?
Right.
So this O minus here, let me make clear that up a bit. So this O minus over like the orange one here, I'll make it pink here, just forms from this attacking that,
Right.
right? And the O minus, like it can just get like protonated from the environment. Um, so it can turn into an OH, and
Hmm.
these guys, just leave as H2O.
Right.
So I would say there's two ways of approaching this. So one is like, the really, really like not perfect, but like proper way of like to really kind of show that you know everything here is to be able to to be able to understand what happens to compound three like before the dehydration, like this thing here, the
Mm-hmm.
synthesized product that's not shown. So yeah, so if you can, draw something like this, like as you're, well, maybe not as you're reading it, but yeah, ultimately, if you can just understand that this turns into this, like you're good. You're really, really good.
Okay.
All right. But let's say that you can't, like you can't get to that step. What we can then do, right, is look for molecules that look like this, but add water to it and make sure that we have a H2O attached to these compounds,
Okay.
right? So let's look at those choices again. So we have um okay, so just scroll up a little bit more so I can see those. Here, I'm just gonna clear this and just go up a bit so I can see these. Yeah. Okay, so here we could, so basically we want something that looks like this or this, but with another H2O somewhere there, right?
Oh
So,
wow.
mhm. So basically these carbonyls are not going to change, right?
Mm-hmm.
So this and this is out, right?
Yes.
And then it's so then these guys have OHs, which is what we're looking for, right?
Mm-hmm.
But that accounts for the OH, but for water it's H2O, so we just need one more hydrogen, right?
Mm-hmm.
So where can that be? So there's one hydrogen here,
Mm-hmm.
and here there's two hydrogens. And if ultimately, when we get rid of the OH group and one of these hydrogens, we want there to be a double bond left over.
Right.
And the double bond means that we want there to be just one hydrogen there, right?
Correct. But what I see here for B wouldn't be already be incorrect because carbon can't make five bonds, and I see five
Oh,
bonds
nice
here.
catch. One, two, three, four. Yeah, nice catch. Yeah, that's a better way. Yeah. Good job. But yeah, let's say that wasn't the case, then you can just see that if we did the dehydration step here, you have no more hydrogens um, on this carbon, right?
Right. Mm-hmm.
We did the dehydration here, you can have your double bond and you can still have a hydrogen there,
Okay.
right? So, I also want to give my students like more than one approach uh to the questions. Um so like one could be like um so like if when we talked about like the blind review, like a blind review would be like doing it the way that I initially did it, where I actually drew the like what this molecule like would look like. But like on the test, you can use more so like the fact that like, so first, you did a good job in that you understood that this question is essentially asking us like basically what's this without or what's this with H2O added? And from there, we could just go through the choices and look for something that looks exactly like compound 4A or 4B, but with H2O added.
Okay.
Yep, yep, yep.
All right.
Hmm.
I completely understand this question now. So
Hmm. Yeah, and I guess the biggest thing here is that with like the words like aldol condensation and intramolecular and like cyclizes and stuff, it can sound very, very complicated, but if you can just bring that into something that is much, much more like simple and basic and like big picture, that's gonna work out for you.
Okay. Um, can with this with this next question, I see I got this one correct. I mean, I only missed one question out of this whole thing, which
Oh,
is
okay. You're good.
okay.
Hmm.
Um, let's see.
Oh yeah, so you
Is
said something
yeah.
about dimensional analysis, right? I think in your email you said something about like dimensional analysis.
Yes, so I ended up flagging this question
Yep.
because um I flagged it. I was spending way too much time on it. As you can see, I spent 3 minutes and 38 seconds, and that was before I flagged it because I was trying to do dimensional analysis in my head, and it just was not working. So I said I'll just come back to it
Hmm.
towards the end, and I completely guessed on this question.
Did you
I
say
didn't even really look at it.
do it in your head?
What'd you say?
Did you say you were trying to do it in your head?
No, I wasn't trying to do
Okay.
it in my head. I was just trying to
Yeah.
um I was trying to do dimensional analysis with this question because I did not remember the
Uh-huh.
equation. If I knew the equation, it would have helped me,
Yeah.
but I
Yeah.
didn't remember the
Start
equation.
with that Miles down essential equations deck.
Hmm.
Now, okay, so now on the test for calculation problems, these can be really big time sinks because it like feels like you know like you know what you're like doing and it's like you do the math and it's like okay if it doesn't give you your answer it's like okay but I know what I'm doing so maybe I just got the math wrong and then it just makes you want to like do the math again so and that just very easily becomes something that you can spend a really long time on so I would say for
Hmm.
these calculation problems like uh do your first attempt with the math. It doesn't get you your answer, just flag it, make a guess, flag, move on. Ideally, like we can talk about time at some other point, but ideally, like like if you it's good that you're flagging stuff because uh yes, like all the questions they all differ, dramatically in terms of how much time they take. Um
Hmm.
and how difficult they are. But they're all worth the same amount of points. So you don't want to spend like three times or whatever to answer a question when you could spend that time to answer like two other questions, right? So
Right.
in terms of time, I would say like for calculation problems, do your first calculation. If it doesn't get you your answer, just guess, flag, move on. And ideally, if we have time at the very, very end, we can come back and do it. But yeah, that's just going to be a time thing. Now let's see. Okay. The total amount of charge and energy, respectively, that the capacitor will store if it's connected to the battery on the rail car. Okay. Now, on something like your blind review, I would say that you could, so if you don't know your formulas, the units will help you out. If you don't remember the units, the formula will help you out. So I would also practice deconstructing units. For instance, like F equals ma, and
Hmm.
force is in newtons. Mass is in kilograms. Acceleration is in meters per second squared. So to be able to say that a Newton is a kilogram times meters per second squared, like something like that. Like that's what I mean by deconstruct. Now work, do you remember what that was?
Work is equal to force um times distance.
Hmm.
So force could also be mass times acceleration times distance, and sometimes it'll be mass times gravity, which is 10 meters per second squared times distance.
Good, good, good. So, and we can and we can think of work and energy as kind of like interchangeable, right?
Mm-hmm.
Okay, so okay, charge and energy. Um, okay, so like I guess let's say okay, if we didn't remember the equations here, how would we do it? Um, let's see. So we have oh, so okay, wait, they're talking about a capacitor, which is where's the capacitor? Oh, here. 100 millifarad capacitor. Oh yeah, and then I would get into the habit of um so like I for ti scientific notation I like to use like capital E.
Mm-hmm.
It's just faster. Like instead of write so like if instead of writing 100 times 10 to the negative 3 farads, I would just do 100 capital E negative 3 farads. And like this, I this could take some practice, but once you have it down, it's going to be super, super useful.
Mm-hmm.
And so I would just get into the habit of writing, like if you had to write out any of these values, to write it like that on your first go. So you already have it in terms of in SI units. Same thing with like, okay, 600 nanometers. I would just write 600 E negative 9 meters.
Mm-hmm.
So just something like that. Um, okay. Charge
I
and
think I completely skipped over the 100 this because every other number is highlighted except this.
got it.
Yeah.
Well, I guess like so there's these numbers, there's 80%, which isn't, I guess, really a number. There's like no unit. But yeah, I get it. Okay. So yeah, okay, okay. So let's see. 12-volt, 100-watt light bulbs. Um, okay. So let's see. So I'm trying to think of like how we can approach this with um out knowing the formula. So, okay, we have the capacitor thing. We have 12-volt light bulbs. We have the power of the light bulbs. Um, and we look at these numbers. So I see like something with like 0.12, which is kind of like 1.2, just, off by or different by a factor of 10. 14.4, 7.2, so 14.4 is like double that. 1.44, 0.12, so the 0.12 up here is on that side, and then 1.2 is on that side, and then 7.2 is here, and then 14.4 is just like 1.44, just off by order of magnitude. So like that's just like I guess like looking at the numbers and seeing like okay, so they all have some type of pattern to them. There's like a 12 or a 1.2 or something like that definitely there in all of the answer choices.
Mm-hmm.
Um, there's a 1.44 and a 14.4 in two of the answer choices, and then there's a 7.2 in two of the answer choices. And like, okay, now this is going to be kind of like cheating with the formula and stuff, but um, your So okay, actually this can kind of be helpful. So like for instance, do you remember the kinetic energy formula?
Kinetic energy is equal to 1/2 times mv squared.
Good. And
Okay.
now your gravitational potential energy is mgh. Now, every other type of potential energy formula is going to look like the kinetic energy formula. So if we had like elastic potential energy, it'll be 1/2 kx squared. If we had the energy stored, potential energy stored in a capacitor, it'll be 1/2 qv squared.
Mm-hmm.
So that can help with remembering the formulas. Just that like the kinetic energy one, it's like you know that and gravitate like and then also when people say potential energy, you want to be specific in what type. So like if it's gravitational potential energy, it's going to be the MGH. But for every other type, at least for this MCAT of potential energy equation, it's going to look like the kinetic energy equation.
Okay.
And so it has a 1/2 in it. So I'm looking at this and this as being double this or this,
Right.
right? So that can kind of point you in the right direction. Um, and then since it's the potential energy that's the 1/2, then even though this is 7.2, which is 1/2, that's for they're saying that's for the charge. So that's
Mm-hmm.
out. And so this could be something that you can do, like, if you didn't, I mean, like, granted, this means that you have to know at least the 1/2 part. Uh,
Mm-hmm.
but that could be like an approach if you didn't know the formulas and if you just kind of like looked at the numbers and you kind of looked for like patterns like that. So that could be something to do. But yeah, I would say before, yeah, like by the end of this week, just to have that essential equations deck completely memorized and to be able to deconstruct units really well.
I do have one question though.
Yep.
When it comes to energy,
Hmm.
the first thing that comes to mind when I see joules is
Energy.
kilograms times meters squared divided by seconds squared.
Uh-huh.
That did not really help me in this sense because I think I ended up doing the math for that equation and it took me completely off
Oh,
track.
so
So,
yeah. So your your gravi universal law of gravitation is this, right?
mhm,
Which exists between masses, right?
yes. Hmm.
And now if we imagine like so let's say we have so it's like, mass 1, mass 2, and the distance between it is r. Now, let's imagine instead of just doing it between 2 point masses that we want, let's say, mass 1 to be like the Earth,
Hmm.
and we want to like zoom in over here on like the surface of the Earth so much that we're on the surface. On the surface, like let's say this is the surface, it's like it appears flat, and the field lines, which, would go like, kind of like perpendicular to the surface here, like on the level of like the surface of the Earth, would just be these perpendicular field lines, right?
Right.
And like so let's say this is you like on the surface. So on Earth's surface, you're in a uniform gravitational field. So if we just plugged in the mass of the Earth here, the radius of the Earth, and g is a constant, this entire thing turns into little g, aka the 10, meters per second squared. That's where that
Yeah.
number comes from. But you could also think of this as 10 newtons per kilogram, which means that an object experiences 10 newtons of force per kilogram that it weighs on in Earth's uniform gravitational field.
Right.
So that's why we can simplify this if we're talking about like on the surface of the Earth as this mass 2 is going to be like the mass that you're dealing with if you're doing like, something times the little g, right?
Right.
Okay. Now for electricity, Coulomb's law, it's the same form, right? Between 2-point charges this time, right?
Oh.
hmm
Mm-hmm.
And so, and like, a lot of times they'll give you like some parallel plate kind of thing where we have some uniform electric field within this with between these plates. So, and the distance between the plates is already, standardized. So this entire thing can also just turn into capital E, which is just the electric field strength.
Mm-hmm.
And just like this, it'll be the force that something experiences in newtons per, instead of kilograms, per coulomb of charge. So, in other words, if we're talking about gravity, we must be dealing with masses because if something doesn't have a mass, it doesn't feel gravity. And
Right.
it's not going to be subject to the gravitational field. And then the same thing with electricity, or the electrostatic force, which is between charges rather than masses. Um, so, so basically, if you took like, I don't know, some mass here that is not charged, it's not going to be affected by that electric field at all. Same thing with
Right.
in Earth's, like if you have an electron or something, which we say doesn't have a mass, it's not going to be affected by a gravitational field. So ultimately, oh, and then this is also how you can get like QE, like you've seen that one.
Yes, I have.
Yep, so that's just like this, except instead of the mass, we have the Q, which is that. And instead of the G, so the little g is just the gravitational field, the uniform gravitational field on Earth. This is the uniform electric field of whatever thing that we're talking about. Okay, so that's that. So ultimately, you were saying that when you're thinking about energy, you're thinking about the um, kilograms thing,
Mm-hmm.
right? So that will be present at least in the numerator with the newtons, because newtons has a kilogram term in it. But um, but yeah, that's the only place where it'll it'll be. Um, as opposed to like, something like this, where this could be 10 kilograms times meters per second squared over kilograms, where that cancels, and that's how we can get this.
Right.
But here, we can't get anything like that because we're going to end up with essentially kilograms times meters per second squared over coulombs. So the kilogram term does stay, but only because the Newton force term stays. And um and since force times essentially like distance gives you your energy. Um, yeah, that can affect things. Um, but yeah.
Okay.
hmm
All right. That makes more sense.
hmm
I'm not sure what happened, but
Yep.
I just flipped them.
Yep.
I don't
Yep.
know.
Yeah.
So,
So yeah. So basically, like, yeah. So just make sure you get those equations down. Um, and like, and you can remember things by like grouping them. So like I would just think like, okay, kinetic energy has a one half in it. Why? We don't need to know, but just it does. And that's kind of weird about it. And then you can just think, okay, then all the other energy terms except for gravitational potential energy, that's the only one that's an exception. Like, so if we're dealing with this or this, um, yeah, they're gonna have a one half in it. So pretty much just that. So,
okay.
yep. All right.
Okay.
So yeah, so we'll wrap up, but yeah, and just like really quickly about this, the entire idea behind the Doppler effect is that if the distance between the source of the sound or the light or whatever and the observer is decreasing, which means either the source is moving towards the observer or the observer is moving towards the source. I like combine them by just saying the distance between the source and the observer is decreasing, getting closer. That observed frequency is going to be higher.
Okay.
And when they are at the same position, they'll be equal. Like the observed frequency and the source frequency will be equal. And then when the distance between the observer and the source is increasing, which means either the source is moving away or the observer is moving away, that observed frequency is going to be lower. And you can think
Okay.
the sirens of like a ambulance or something like that. Like if like let's say you hear, I don't know if you have like traffic or stuff like that near you. Where are you located?
I'm in Philadelphia.
Okay, okay. So yeah, so if you hear like a siren and you just kind of think about like, okay, is the pitch of that increasing or decreasing? You can tell if that source of the siren is moving like towards you or away from you. Yep.
I think I just misread this question because it says the rail car is passes by a horn. So I was visualizing it
hmm
and it's emitting a sound.
hmm
So I was thinking like it's starting to approach it, but it seems to me like when it says passes by, it's like getting further and further away. But because I'm on the time crunch, I didn't really think about it. So I was like, it's definitely not C or D. So I was like, okay, it's got to be one of these. And I think I just completely misinterpreted the question, which happens a lot. So,
Got it. Yeah, so it does say passes by, so it's already gone. Uh,
right.
but yeah, in the choices, you have like, okay, what happens before passing and what happens after. And if it's like passing it, which is like right in the middle, before passing it, it's moving towards it. After passing it, moving away from it. So that's why you'll get the higher frequency before and lower after. But
Okay.
yeah, awesome. So yeah, oh yeah, let me share that spreadsheet with you. And yep,
And I have one question.
yep.
So, when it comes to doing review on eWorld, so what I've been doing is just taking 59, like the max amount of questions, 59, and I just add all different types of questions in there.
Hmm.
Psych socials in there, physics, chemistry, biochemistry, cars, but I'm going to take that out now. Is that really a good strategy? Because I'm trying to get exposed to these questions every single day. Or should I just, I think that's why I'm not able to kind of pinpoint where my weak points are. So is it better that I just go ahead and do section by section by section
Yeah.
instead?
Yeah, so I would say based on like, your like either your performance on the content diagnostic or your performance on the full length or even this one. So like for this one, I would basically make a UWorld thing for so like the Orgo stuff, it seemed like you had a decent handle on, but this one less so. So I would like prioritize like capacitors, electricity, some like physics stuff. So yeah,
Right.
I would do it that way. That way you get to focus on, that specific subject, and then you can use the spreadsheet content tab to be like to check it off and be like, okay, I understand this now, I understand this, I need to work on this. And that way we can go through each of the topics and give each of them the appropriate amount of time and uh, work that's required. So yeah, I would say doing it like that instead. So yeah, so I would say to focus on particular topics when you do that.
Okay.
Yep.
Okay. Well, thank you so much.
Yep. Totally. All right, let's see. So
I think I did get the spreadsheet.
awesome. And you said you had Zell?
Yes, I do.
Okay. Putting my number in the chat and let me see. You said that the YouTube, so like the 85. Okay. Let's see. Should be 156.
Okay.
And oh yeah, I'm gonna share with you a Google Drive with a lot of really, really useful stuff.
Okay. I'm going to go ahead and send it to you now.
Hmm.
So your last name is
Khalid?
Kali. Yeah, okay. I just want to make sure I got the right person.
Yep, yep.
Okay. You should receive it.
Okay. I got it. Awesome. So you can use my Calendly to schedule for, next time. And you have a
Hmm.
spreadsheet and everything like that. Anything else?
No, that is it. I'm definitely going to stick to that spreadsheet I think I just need some structure, like
Uh,
what I need to do. So I'm actually gonna head out for a few hours, and then when I come back, I'll definitely go ahead and go over. I'll start on the um, question bank for Jack Weston.
awesome. All right. Pleasure meeting you and
Yes,
hope to see you soon. Good luck and take care. Have a good one.
you too. Bye
Yeah.
bye.